So welcome to the April webinar for PhycoTerra. Thank you for taking time out of your day to attend the session, and we really appreciate it. Today we're going to be talking about choosing the right carbon product for your field, and we're going to have a really nice discussion on this space that is has a lot of attention right now, but it's still a little bit noisy. So if you're here for some clarity, I think we can provide that. And just in case you're wondering, that guy in the field on your screen, that's not me. I'll show you an actual picture of me if you can't see my video. But I'm Dr. Karl Wyant. I'm the Vice President of Ag Science here at Heliae, and I've been in this space for a while now, and I think we're headed in the right direction on providing some transparency and some clarity to help folks make the right decision to choose the right carbon product for their field. So with that, we'll get started. And I'll do some quick housekeeping, and then I'll go into the presentation. So I just did my welcome. I'll go through the presentation. As per certified crop advisor rules, we will need to do the CCA credit at the end of the talk, and you'll get 1 hour. That's a half hour for nutrient management and a half hour for soil and water management. I do have the QR code. I have verified that it works. So if you have that CCA app, please get it fired up and you can get signed in. If you don't have the app, I will give you a way to get around that, and the instructions will be on that left slide of the presentation. I do have manual paper sign-in sheets here next to me, and we can get you taken care of. And then, of course, we'll have some time for the Q&A session. So if you have questions, please put it into that the chat or the Q&A, and we'll answer them at the end. So let's get started. So I told you that first guy on the slide wasn't me. Here's my headshot from Heliae. But just to show that I'm a real life person, I've been in the soil game for a long time. I used to work in the eastern Colorado on soils and really just learned how to dodge rattlesnakes and cattle. Took a soil sample somewhere in between. For my master's, I went up to the permafrost, worked in Alaska. It's a good way to learn that you don't like working in freezing cold conditions. So I said, hey, I'm going to go do my PhD where it's hot. So I came down to Arizona State University and did my PhD in desert soil science and got introduced into agriculture by way of working on some vineyards that are here in Arizona. And so I moved into ag retail. I was an agronomist and worked in precision agriculture. Did that for a number of years from Arizona to throughout California. Had a really nice time. And then a couple of years back, I transitioned into this vice president role here at Heliae. So a really nice way to kind of see a lot of different agriculture, see a lot of different soils, and understand how do these carbon products fit into this marketplace. If you want my contact information, I'll have it at the very end of the presentation. If you want to do any more detailed follow-up, I'd be happy to answer any questions. Or if you just want my headshot, be happy to send you a signed headshot with an autograph and everything, if you really want that. Let's move on to just talk about who Heliae is. I've mentioned that several times. Heliae Agriculture is located out of the Phoenix, Arizona area. Right now is a great time to visit us. Don't wait till the summer. It's a little hot down here. But here at Heliae Agriculture, we grow microalgae, and that's our product base. We've perfected the art and science of it. And what we've been able to do is take that microalgae and turn it into agricultural products. So PhycoTerra Organic, and our PhycoTerra seed treatment product. So we're players in this space, and we use this microalgae to feed the soil microbes, the bacteria and fungi that are either in the ground or you're adding in with other products. So that's where this expertise in the product space comes from, carbon products. Now because we've been in this position for a while to say, here's what our product does. Here's what other products do, like humic acids and seaweeds, and really helping to provide some of that clarity to the marketplace, what they're looking for. And you'll see just how noisy it is. And I think educational efforts like this webinar today will really pave the way forward. So we produce microalgae. We produce a pasteurized soil microbial food, and that helps wake up the microbes. So I'll introduce this PhycoTerra again in a few slides, but just so you have some information. Just in case you wondered what microalgae looks like, it's really hard to see. It's microscopic. It lives in the soil. Here's a picture of microalgae. It takes 6,000 of those guys lined up to make a quarter of an inch of distance. That just shows how small they are. They're plant-like. They turn sunlight and carbon dioxide into biomass. And what we've been able to do is perfect the growing of that biomass and then pasteurize it and then make a food source for the microbes that can go out through all kinds of ag equipment and be blended in with a lot of different liquid fertilizers and crop protection products. So I mentioned who we are, but let's just kind of go back and talk about this product category, the biostimulants, the biologicals. I'm going to call them carbon products because that's what they have in common. They're all made out of carbon, but of course, carbon chemistry matters. What you're doing with that carbon gives it that function at the end of the day, so you can best choose what's the right product in the category for my field, for my growing operation. How do I make sense of it all? And that's really been a huge problem. You just heard me mention all those different names that we call this category, and a lot of that has to do with some of the regulatory vagueness that's in the product space. So I'll refer to them as carbon products because that's the chemistry, that backbone that they all have in common. But I think really let's just talk about where's this thing going. And I'm going to break my talk down into clarifying the marketplace, talk about some of the regulatory changes that are going to happen for those of you who love the regulatory piece, and then really get to the meat of it. How do we make the right decision for our field or for our growing operation despite all this noise? And so PhycoTerra products are part of that conversation. I'll show you how to slot that into to your grower goals and to your advising goals. And then we'll kind of break out other products, and we'll have some nice follow-up at the end and after the webinar on just finding the right fit. So this product space, whether you call it carbon products, microbials, biologicals, biostimulants, lots of different names, really the same bucket. It's these things that are, other than fertilizer or crop protection, things that are often derived from natural sources that have an impact in the field. Lots of interest in this space, and it's certainly been growing over the last 2 or 3 years. Here I have some articles on the screen that you can look up. Here in tomatoes, and Progressive Crop Consultant, great media resource for coverage on biologicals. And West Coast Nut, how to fit microbials into almond production. So lots of interest. You see this category growing. I get asked about it every single day. I'm certainly that some of you are asking that question or having to answer that question, and that's why you're here to help provide some clarity. One thing we also see catching up is the academic and extension support, where they've taken a very deep look at how these products work. So here's a great example from Plant and Soil, agricultural uses of plant biostimulants. That's on the left side of the screen. And just talk about how do the products work? What is the mode of action? What do these products do best? And then some other reading here from the Florida Extension Service, just helping us make sense of it all. And that's the challenge here, is making sense of it all and assigning the mode of action to the active ingredient. What's in the product? The carbon chemistry defines what it does best. So that's what I'm going to walk through. And so I've pulled all these resources from this literature, and I'm hoping that you walk out of here with some nice, clear points of view where you can make some decisions on your farm this season and provide the right type of carbon product for what you're trying to get done. So here's the problem. One of the problems is there's so much noise in this space. This is a chart that's from an Agrison paper where they charted just these different active ingredients and where they fit in. And I know you've really got to squint and find your favorite product here, and just thinking, what is my active ingredient doing? How does it fit in? All the traditional players are in here. Here we have humic substances. We have some of your seaweeds and kelps. We have protein hydrolysates. We have, just lots of different active ingredients. So there's fulvic acids here. So much noise, so many ingredients, so many products. And people come to me every day and they say, I don't know what to do. Which one should I choose? So that's what we're going to answer today. Which product should I choose, or which approach should I take based on my goals? and I'll help walk you through some of the chemistry that determines which one on this list or this Venn diagram that you should be looking into. So I'll do the regulatory update very quickly, and this has been such a challenge in the space. One of the challenges is we don't have a strong definition about what is a biostimulant. And I mean that from a legal regulatory standpoint. We haven't figured out quite where we're going to land here. Very unclear definitions. If you want to read the 2018 Farm Bill, look on page 419. You can find some examples of this vagueness. The EPA, of course, wants to make sure everyone's doing the right thing on a regulatory and claim standpoint. So they've had some draft guidance that came out a couple years back. And one of the goals of the EPA is to clear up label language claims and sort out some of these FIFRA categories, the body that decides are you exempt or do you need to go under the same regulation as a pesticide or fungicide, that sort of thing. So lots of challenges here. This is if you really want to see the dynamics of the regulatory network at play, this biostimulant area has been a good place to watch because it's just been so busy lately. And one piece that's happened is this category, depending on the state you're in, some of these regulatory categories that states have, sometimes they call a biostimulant a fertilizer or a PGR or ag chem or an exempt or unclaimed. So there's a lot of loose ends here. I imagine they'll be tied up fairly quickly within the next few years, and our industry will be able to move forward with a lot more clarity on this carbon product space. But for now, I think some of this webinars like we're doing today will really help put us in the right direction to get you thinking about modes of action, active ingredients in that product, and how it slots into your goals. So if you want to read all this, you're more than welcome to. I've done it for you, so I would save the time. Let's focus more on taking this different view of carbon. And this is an interesting piece because when we look at soil carbon, we tend to think of that soil organic matter percentage on the soil report. I'll show you an example of it here in a second. But I want you to kind of open your mind up a little bit at the top of the call. Maybe you've got your fresh cup of coffee in your hand and really think about carbon products. I can add properties that I desire with carbon products to my soil to get some work done. And that's what I'm going to show. And that's like, I think, the fit of these carbon products in this category. But of course, we've got to talk about, what do these products do? When we think about high performance soils, high performance soils, think of your best field that you have. If you wouldn't have measured it, you'd probably find these boxes all checked. You'd have a good microbiome, that microbiome, fungi and bacteria. The soil is alive, it's up and running. Check that box. You'd have plenty of plant available nutrients from your soil itself and from your fertilizer program. Check that box. You'd have excellent soil structure, good aggregation, water holding capacity, and drainage. Check that box. The piece that we haven't measured a whole lot is this carbon piece. We've done plenty of work on passive carbon. That's that soil organic matter. I want to talk to you today about this active carbon because this active carbon really is the fit for this carbon product category because you can actually add soil health-like properties with these carbon products. And I'll clarify that here in a second so you can see what I mean. This active carbon is very amenable to your management practices. Of course, that's the products you're choosing to put on the field. So we can influence that active carbon and provide these high performance properties that you're looking for. So I'll clarify that as I move forward. I wanted to show you an example of a great place to start when you're thinking about carbon products, a soil report. And you can derive a lot of information from here. You have all your nutrients listed here, so you can derive that perfect fertilizer program. If you live in a place where you have salinity issues, here's sodium, you can write your salt reclamation claim. If you're looking for information on, how prone is my field to leaching, you can look at that cation exchange or even the saturated paste percentage or texture if your soil report has that. One piece that's challenging with understanding where a lot of these carbon products come into play is we don't have a lot of information about carbon on a soil report. And that's usually only represented in this organic matter. Here it's a 1.7. I don't know where you folks are all from, but that's a nice number for Arizona, where I live, in parts of the Western United States. But that's the information about carbon that I have to work with. Now, I mentioned the two kinds of carbon, passive carbon and active carbon. So this organic matter number is not telling you how much of each you have. It's just telling you the total. So that's the challenges. And I'll unpack that organic matter number a little bit and show you just how to measure active carbon and just show you how small that active carbon is as a percentage of that total is. And that's really what we're going to try to manage with our product choice. So let's move on to this carbon fractions. I promise it won't be super math heavy. So don't fall asleep on me. What I want to do is show you this pie chart. And what this pie chart represents is that soil organic matter percentage. On the soil report before, it was 1.7%. Here I'm actually breaking it down into the passive carbon, which is that dark navy blue, and the active carbon, which is that turquoise color. And so you can see just how small active carbon is in terms of your total carbon. So that's what we're going to try to influence on our management strategy. And you can see just how small that pizza wedge is relative to the whole pie. So let's talk about active carbon. Active carbon is generally 5% of your total soil organic matter number. So whatever 5% of 1.7% is, some of you with your phone calculator nearby, crunch that out. Very, very small. But this active carbon has the highest utility. Like, how usable is it? Active carbon does a lot in your soil. It feeds the microbes. It helps aid in NPK release. It helps influence aggregation and structure. It helps influence water holding capacity and water infiltration. And you can also use that active carbon for those products to drive strong cation and anion exchange capacity, chelation and complexation. So it's a lot of work that gets done in this very tiny fraction of the total soil carbon. And when you go measure this, and I'll show you a way to do it, a lot of grower soils are low on active carbon. It's even smaller than 5% in some of the reports I've seen. It might be 1%. That pizza wedge just keeps getting smaller and smaller. But that's where you can bring a management strategy into play, open that pizza wedge up, get the utility that you're looking for. The passive carbon, which is the majority of what you're seeing on a soil report, this is super useful. It's the stuff that we think about with carbon sequestration. It's the stuff we think about with some of these broader soil properties of how dark is the soil. That's a slower, a more passive carbon pool. It's the majority of your organic matter reading, but it doesn't have nearly as much utility as the active carbon fraction does. It has a weaker influence on exchange and complexation and chelation, a weaker influence on structure and water relationships. However, it has a weaker influence. It's still important, but this slow passive fraction takes a long time to influence. If you've ever built carbon in your fields, this is what you're trying to build. That's a year-over-year program that you commit to. In contrast, the active carbon, you can manage it this season with the right product choice. You can get those properties that I'm showing you here with the right product choice and have an influence on your active carbon. So I mentioned active carbon a couple times. What is it? This is actually a soil pool, and you can measure that soil pool. So if you have a sheet of paper nearby, this is something to ask your soil lab for. Hey, can you measure active carbon? There's some other names they might call it, permanganate oxidizable carbon or POC. They can tell you how much active carbon is in my soil. And if they've done their homework and done the indexing, they can say, hey, you're very low, high, give you some sort of interpretation to help you make that decision. I need to boost this part of my portfolio for my field management because I know I'm low on active carbon. So this active carbon is interesting. It reflects that piece of the pie that's super useful. One reason you can use it is to how much food do I have for microbes, so I need to add a food source. And you can find those other useful fractions like the am I going to be low on holding on to nutrients, that sort of thing. So you can get a lot of utility around it to help you plan your carbon product. The nice thing is it responds within the season to management programs. Once you start going down this route, introduce some of these carbon products into your portfolio, you should see that active carbon parts per million, that's how it's measured, start to go up. So very adapted to management programs and lots of utility. So just ask your favorite lab, can you measure active carbon? And then they should be able to help you out. So here's my sort of thesis here. Active carbon substances have utility. They have a ton of use. They're rare in the soil sort of carbon profile, but they have a lot of utility. And I'm going to walk you through like the two flavors: living inoculants, they're made out of carbon, and then what I call the dead or non-living carbon. That's where a lot of folks kind of get confused on the chemistry. So we're going to talk about species identity and function, and then move into the dead carbon products, the non-living carbon products, and talk about those specific chemistry points of view that help determine the function. So lots of interesting content coming up, so stay tuned. So let's talk about living carbon products. So if you've ever been wondering, well, what does all this stuff do? Because there's a lot of microbial products on the market, whether they're a Brady rhizobia or a bacillus, a pseudomonas, an aspergillus, lots of products. And a lot of folks ask me, hey, what do these do? What's the function? So I've gone through the literature and I've actually plotted these out in a cheat sheet, and you'll get a recording of this talk here later today, so you can reference it back. But here are these inoculant cheat sheets. This is the fungi one. A couple of different sort of greatest hits here. You have yeasts and proteins. Those help deliver nutrients to the plants, amino acids, NPK. Trichoderma, that's a beneficial fungus that helps protect the plants against pathogens. And then you have mycorrhizae. Probably the more famous one is the mycorrhizae. A lot of great mycorrhizal products on the marketplace, but these products help promote that relationship between the plant and the fungus to help trees. I'm using trees as an example, but it could be any crop. Get more water, get more phosphate. I said any crop. Let me back up. Any crop except for some of the brassicas. Brassicas don't form a mycorrhizal relationship. So if you're outside of that, you're good. So one way to use this cheat sheet is when you're looking at your product. Find the genus, the Trichoderma or the mycorrhizae. Find the species genus name or the broader category, and you can help relate it back to the function. The fungi are relatively simple. It's the bacteria that are more challenging, and that's where we have these different genuses that you need, or genre that you got to look at. So Brady rhizobia, probably the most famous one. They're the ones that help form the nodulation in the legume crops. So a lot of Brady rhizobia goes out on soybeans and peanuts and things like that, alfalfa. And then you get out to these other genuses, genre that are more difficult. So Azospirillum, that's been a lot of talk about Azospirillum lately. These are those free living bacteria that help with infixation on non-legumes. So a bacteria that'll fix nitrogen, provide nitrogen for a corn crop per se. So that's the function. You have Bacillus and Pseudomonas. They're popular products. And these are products that often are touted for their assistance with nutrient availability, and some of the literature shows that they help with some of those suppressive soils for pathogens. And then finally, just to shorten this list up, the Aspergillus species. These are the bacteria that help produce enzymes that break down hard to digest plant fibers. So it can help you with some of that residue management and things like that. So lots of different opportunities for inoculants. Here, if you're trying to make sense out of it all, you can look at the category, like a mycorrhizae. Here I'm showing different genre, and then relate it to a function and help clarify that space. One piece that's happened is with the inoculants is that they work well, but you're trying to keep the bacteria or fungi alive. And that's a big challenge with these inoculants. Viability during transport and storage, always a concern. How alive is it by the time I'm going to the field after it's worked its way through that supply chain? Once you put the bacteria or fungi out, of course, you're bringing that foreign microbe into an area that it might not be very happy in. Moisture fluctuations, temperature fluctuations, UV, it's always an important one. And then competition, how well does it compete with other microbes to get established and get going? So these are challenges that have been reported to me through the years. Folks that have used these microbial inoculants, some with great success and some folks that are still scratching their heads. So if you have concerns about how viable is a product, how alive is it by the time you get it to use on your farm, some labs can help you match up the CFU count, the amount of living microbe that's on the label, and give you an count that's actually in your jug. So if you need to confirm that, that's a great way to do that. And some products in this space, their label matches their final delivered count very well. Some other products don't match as well. So if you're evaluating these types of products, that's a great way to try to understand it. How alive is a product by the time I put it out? And then finally, the one challenge with inoculants is you can't just mix it with anything. Because you're trying to keep something alive, there have been issues with mixing and compatibility. Ride to the field, that's so important. Getting the product into the UN32 or the 1034O or mixing it with the glyphosate or a seed treatment package, that's a challenge with some of these living bacteria and fungi. So that's something to pay attention to. And your product rep, of course, can help you walk through that. What's a no-go on mixing and what works just fine. So keep that in mind. I'll move on to the non-living carbon products next. Excuse me. And I'll do some work on microbial foods first, and then I'll go on to some of the other products that are active ingredients that are in this space, the humics, fulvics, and seaweeds. And so let me jump into it. One piece we've learned in this area of carbon products is that feeding your microbes is a great way to influence your soil health. So I'm showing you a slide here, and this is with PhycoTerra, our microalgae product. Of course, it has carbohydrates, proteins, and lipids in it. So here we're showing how we've taken sort of a business as usual soil. That's the plate that's on the left side. And what we've been able to do is take that business as usual situation, add in the PhycoTerra. That's why this plate on the right is green. Our product's green. Looks like a liquid green smoothie. And so add the PhycoTerra to it and wake up that abundance and diversity, and then start to use those microbes. They like to secrete glues. The fungi tie particles together. Fungi also secrete a glue called glomalin, helps to stick your soil particles back together. When you have a functional microbiome, you get those benefits. You get the glues, you get the nets. And that, of course, gives you an ability to start influencing your soil health. And here I'm showing you just in the aggregation and structure change. What you're not seeing is that influence on water holding capacity. Soils that can get through drought. We see some drought conditions coming this year. Soils that can get through drought have a healthy microbiome, abundance, and diversity. And so if you haven't looked into microbial foods yet, this is a great time to do so, especially if you know you're low on microbial food, you did the active carbon test. That could be a good way to make that decision to spend those dollars. So I'd like to talk about food. And I know it's almost lunch, or maybe even lunch right now for some of you folks on this call. So let's go back to something maybe our moms told us when we were young. You are what you eat. So I'm gonna give you 3 different lunch options here: a bowl of sugar, a bowl of wood chips, and a turkey sandwich. Thank you to Google Images for providing these very quickly. But I want you to think about, if you're going to feed the microbiome, what are you feeding them? So quality of food, quality of the diet, because these all have carbon in common, but what it's made out of, and what the food is actually consists of, the lipids and proteins and carbohydrates, kind of help determine where you can push that microbial community. So let me open up this next part of the slide here. So I'm pointing to some products that I'll do some spotlight on. Molasses, of course, made of mostly sugars, carbohydrates. Humic acids, it's carbon, but it has a C to N ratio and a size. It's kind of like eating a big bowl of wood chips. Sure, you can eat it, but are you really going to have a good time? Especially if you're a microbe. Please don't do this for lunch. Let's take it to the hospital. Or you can have a balanced diet, proteins, carbohydrates, and lipids, and that's more like a turkey sandwich. That's my way of referencing the different diets and quality of diets that are in these food products. And so I have this table arranged. We've done a lot of work looking at the food chemistry of these inputs, and so I have it arranged just from left to right. How much food can you deliver? Like, how big is the meal in a liter of product? So they're usually a liquid product that we've measured. How much food can you deliver? So size of the meal. Here you have what you're feeding them. So this is that sort of sugar versus bowl of sugar versus wood chips versus a turkey sandwich comparison. And then how pure is the food? That's the ash that comes out. So stuff that the microbes can't eat, that structural material, some things that are just hard to digest and aren't a good food source. So I'll open this table up and I'll just walk you through it. If we start with this grams per of food per liter, you see molasses and our PhycoTerra, they have a similar food load per liter. Humic acids, not a lot of food. I'll get back to humic acids. They're one of my favorite carbon products to work with. But they have a much better role. They don't deliver a large food source per quart or per liter, but they have other functions based on their carbon chemistry. I'm going to scroll all the way over to the right side and talk about the impurity. This is a grams in a liter. Here you see with molasses, some impurities here, relative to the PhycoTerra that only has 3 grams of ash per liter. And when you look at humic acids, not a lot of food in that, but most of it is ash. It's that structural material, the stuff that's really hard to eat. I'll get back to what humic acid and these other products, they have a much better role rather than feeding microbes. Let's choose them for the right role and think about blending. So I'll get to the meat of it here, where these lunch examples showed up earlier. Your big bowl of sugar, here's that carbohydrate grams per liter in a molasses product. Lots and lots of carbohydrates, which later get broken down into sugars. Not a lot of lipids, not a lot of proteins. When you think of humic acids, it already has a low foods delivery load to begin with and a high ash content. But you can see that protein, lipids, and carbs, not a great food source. When you think about PhycoTerra, we've got a really nice balanced diet, 44 grams of carbohydrates, 21 grams of lipids, 24 grams of protein, and a low impurity load. So you can see how that balanced diet, that turkey sandwich effect, really, you can pull it out of some of these macromolecule comparisons. So I'll show you the end result. If you are what you eat, let me show you the influence that molasses and humics have on trying to feed the microbiome. I'll go to the next slide here. Here's molasses. We have it down in the bottom here. If you have to move your Zoom toolbar, please do so. We have a grower standard, and then we have a PhycoTerra comparison. So feeding the soil molasses, you get an abundance response from the molasses. It's a food source, but there's only so many things that can eat all that sugar you're putting in the system. When you feed that soil microbiome the PhycoTerra, by comparison, if you just look at the different colors and you look at the diversity of colors, that's where having that balanced diet, that turkey sandwich, if you will, really has an influence on microbial abundance and diversity. So you want both. You want a functional soil community is not only a bigger community population and abundance-wise, but has all those different jobs turned on, all those different roles filled. And we're getting a much more, a better appreciation here for those different functional roles as we learn about what different groups of the microbes do in the soil. So you are what you eat. Just think about your own lunch, sugar versus a turkey sandwich. What's going to make you feel better at the end of the day? I'll go to the humic acids. And this is just a humic acid product. Remember, it's the carbon chemistry of humics. It's a large molecule. It has a C to N ratio going up into double digits, depending on your source. And so I always think it's like eating a big bowl of wood chips. You can compare the grower standard here versus our humic, and you can see not a big difference. Microbes don't, if they have a choice, they don't want to eat those humics. They're just a difficult food source to work with. However, you feed the same soil PhycoTerra, and that's where you get that big pop in abundance and diversity, because PhycoTerra, of course, has a C to N ratio of 7, right in that sweet spot for feeding microbes. And then we've got that turkey sandwich effect, carbohydrates, proteins, and lipids that help to promote all that abundance and diversity. Of course, and this is the really fun part about this carbon product category, is blending them. And that's what I just underlined very poorly here. Sorry about that. When you put the products together, PhycoTerra plus the humic, that's where you get some really cool benefits. You get the improvement of the microbial abundance and diversity with the PhycoTerra, and you get the benefits of the humic. And so I'll cut to the chase here in a second with the different modes of action of these products. But humics, great at complexing nutrients, holding that nitrate in the root zone, holding that potassium and phosphate from interacting with other things in the soil, and then being antagonized. Now you've got a blend that has unique properties because you've put them together and you've thought about slotting those different modes of action in a way where you can drive benefits on both sides. So let's talk about some of those non-living carbon products. I've been segueing out of this food source. Now we'll go into these other non-living carbon products. Organic acids, I'll split that into fulvic and humic. We'll talk about enzymes, and then we'll talk about seaweeds. So this is a fulvic acid, if you've ever wondered. Great tattoo idea if you need it. But fulvic acids, they're great at holding on to things. So it has a really high cation exchange capacity between 500 and 600. So it can hold on to nutrients like a humic acid can. But the fulvic acid is really small, so that you can actually grab onto a nutrient, keep it in the root zone with a fulvic acid, and then carry it into the plant. It's a really cool way to hold on to things, bring it into the plant. That's where fulvic acids come into play. Seaweeds and kelps. This is an old technology. We've been using seaweeds and kelps for thousands of years on the coasts of northern France and in that area. And so it's macroalgae. I showed you microalgae earlier, the little cells. That's the PhycoTerra. Macroalgae, of course, is Ascophyllum nodosum is a common commonly on the seaweed product labels. Complex variable extracts. When you read through that academic literature, lots of focus on how the seaweeds and kelps help with plant growth, promoting plant stress tolerance. And so there's been a lot of great work showing, hey, if I need to influence my plant stress, a seaweed and kelp is a great way to get there. I used to use a seaweed product to help with heat stress down here in the desert, to help keep fruit on the tree, bolls on the cotton, that sort of thing. So a little bit nuanced of a role here. I had a slide earlier that showed trying to feed microbe seaweeds. Similar response to some of these, like I showed for humics, where the seaweed and kelp, mostly carbohydrates and some structural materials with ash, and not a lot of macromolecule diversity in terms of proteins and lipids. So not the best food source, but it does have a great fit into your crop management program if you keep that mode of action in mind. Enzymes are becoming a lot more popular. And so I'll just break these down. I'm going to use phosphatase as my example. Really common product. If you look at the label, I don't want to mention a bunch of brand names. I'll just talk about the active ingredient. Phosphatase, if you choose to use that enzyme product, breaks down insoluble phosphate into plant available phosphate. So that's the unique thing about enzymes, is that the enzymes are unique. They're produced by living organisms or they can be made in the lab, and they bring about very specific reactions. So this phosphatase helps to liberate insoluble phosphate and make it more plant available. That's its job. It helps to free up that phosphate. So that's one key about enzymes, is that you need to match your enzyme ingredient to the function you need in the soil. So this might be a phosphatase product, might be useful in a soil where you've got some phosphate, you just can't free it up. And so use a phosphatase. So I put together a table for you to reference later. just looking at product labels, here I have protease, beta-glucosidase, amidase, urease, and phosphatase, and sulfatase. And so what I'm doing is connecting these different ingredients to the function so you can best match up what you need done in that soil. So a protease helps to break down protein. That glucosidase helps to break down cellulose. And if you're trying to influence your nitrogen cycles, that's where this amidase or urease comes into play. And then probably more famous is the phosphate and sulfur impact. So you can help release these products. So when you're looking at enzyme products, super useful, just match the active ingredient in the enzyme because it's fairly specific what function it has. And these are just a couple of examples of how you need to match that up. I'll get into humic acids. I mentioned how useful these are. Great product to work with. Same with the fulvics, because of their ability to hold on to nutrients. That's what they do best. They can complex or chelate nutrients like nobody's business. Here I'm showing a picture of a humic acid. Again, another great tattoo idea. One unique thing about humics, dual charge. On the same molecule, they have positive sections, positively charged sections, and negatively charged sections. That gives you lots of utility for grabbing on to different nutrients. Let's just say nitrate, that's a negative charge. Bind that to the humic, keep it in the root zone. The negative charge can grab things like potassium, keep that in the root zone. So lots of utility from one molecule. It's a large molecule. So I mentioned how fulvics can grab nitrate and then be pulled into the root. Humics can't, they're too big. If you think about the length of a fulvic, we'll call that a Volkswagen Bug. A humic is a freight train 100 cars long, just for a size comparison. Big, it's a big molecule, so it's gonna sit in that soil and hang out and release those nutrients later. It won't be pulled into the plant. So lots of utility though with this humic acid. Not the best food source for microbes. It's like the big bowl of carbon. Sure, it's carbon, but there's better things to do. I think I got my bowl of carbon picture from a Traeger smoker website. So use that bowl of carbon to smoke meats. Don't eat it. That's what the meat's for. But yeah, humic acid's great for holding nutrients in the soil and for helping you with that nutrient efficiency plan. So this gets us to this table. And so we've done a lot of work looking at carbon chemistry, looking at the molecular, macromolecular diversity of these products. And so we can say, here's what this product does best. And so these microbial foods, that includes PhycoTerra. We talked about molasses. They're very, very common. Feed your microbes, give them the best diet that you can. And then this contrast with some of these other products on the market, enzymes, living inoculants, fulvic acid, seaweeds, and humics. They all have carbon in common, but their carbon chemistry or their species identity for a living product determines that final function. So this is a fun space to be in once you unpack those modes of action and you can say, what does this product do best? That way you can help assign the right kind of blend to your field. So I like to do, for example, I like to use a microbial food, PhycoTerra, with a humic. So I can feed the microbes and hold on the nutrients. Now I've got a great tank mix partner and a unique blend. So one thing to keep an eye on for your email is some follow-up. We're going to send you a white paper and a recording of this presentation so you have it all for later use. And what we can do is just talk about some of the blend advantages you have when you think about these active carbon, when you think about their mode of action, just like we would the crop protection tank mix, here with the carbon products, really just showing how can we put these together and drive complementary modes of action to get some cool work done on your soil. So let me wrap this up so we can move into some Q&A. This biostimulant or carbon products or biologicals, whatever you want to call it. I don't know if you can see me doing air quotes in my finger with my fingers, but this category is becoming more popular. And I showed some examples from the ag press and from the academic research side. Lots of interest, but it's been a challenge because this bucket, if you will, for the products hasn't been quite unpacked, where we've talked about specific modes of action, and we've talked about this is the best product for this field. Here's a better product for that field. We haven't gotten there. I think that's where we need to mature our thinking here moving forward. So I like to start with good agronomic principles. What does the product do best? What is the evidence that supports that? And how do we help our growers and our crop advisors make the best choice for this season? And so I say that's where that trusted consultant, there's folks around you that know this space well. Of course, here with the PhycoTerra products, we can help you provide some of that clarity because we've done that work already, and that's what we do webinars like this for. We also publish these white papers. You'll be getting one here in a few minutes after the webinar, just to help, just to pave the pathway forward that, hey, not all these products do the same thing. Let's think about the end goal. What do I need to do on my soil to drive success? It might be I need to feed the microbiome. I need to choose a food source. You might have a field that has excessive salinity. I got a call the other day I have excessive boron in my soil. But that's where a fulvic that's where a humic might come into play, complexing that boron away from the plant root and keeping that sodium and chloride away from the root. You might have an issue with nitrate leaching. That's where some of your fulvic and humic plays might be a best fit. So having that mode of action clarity and having some of those data points could give you, hey, this is what the field needs this year, and this is the product I'm going to choose based on its mode of action's best fit that we've talked about today, and that gives you some clarity on how to move forward. I like to focus on blending. How do I put these complementary modes of action together? I've mentioned the humic and the PhycoTerra. That's a dynamite combination. We see good synergy in the field with that. The humic acid complexing the nutrients, keeping it in the root zone. The PhycoTerra feeding the microbe, waking them up, putting them back to work for you. So there's lots of different permutations of this blending. And I think that's for having that end goal in mind and thinking about what can I do in my blend to put my different modes of action together. And I'm sure for those of you who love the regulatory piece, that's going to shake things up. I think we're just going to get more clarity on how this category is defined. So I can stop using air quotes when I talk about the product space. That'll be nice. But I'm sure that there's going to be a lot of shakeup here, and be interesting to see how that moves forward. One piece I wanted to close on is if you're looking for educational resources for this space, please visit www.phycoterra.com. And we have a whole education tab that you can go click, and it has all kinds of material for you, articles, old webinars. Really, it's our commitment to this carbon product space and helping folks understand, where and when to use different active ingredients, different products in their book of business. So before I get to the Q&A, let me offer up the CCA credit for those of you that need to get going. The CCA app will work on this QR code. If you just aim the CCA app at this QR code, it'll sign you in. You'll instantly get your hours. And of course, it's a half hour of soil and water, half hour of crop management. If you don't have the app or the app decides to not work on you, please text me your first and last name and your CCA number at that number that's listed on the screen here. I'll get you signed in, and I'll verify it against the attendance lists and everything. But I've got an old school sign-in sheet here with me. Then I'll make sure you get the credit. I'll send off the sheet to headquarters, CCA headquarters, so you get the hour. So let me leave this slide up for a little while so folks can take care of business on the credit. And I will go to the Q&A and answer some questions. So we got a question: aren't the fungi big degraders of high carbon residues? So yeah, that's a great fit for some of the saprophytic fungi products that are out there, where you're adding that decomposer fungi. The products that I showed were the mycorrhizae, just because how common they are. So yeah, if you're looking to decompose corn stover or wheat straw, talk to your favorite ag retailer about a fungi that does decomposition, because mycorrhizal fungi and what's called saporitic fungi, two different groups. Mycorrhizae help form that plant-fungi partnership to help grab more nutrients and more water for the crop. The saprophytic fungi help to decompose crops residues in high carbon materials. So yeah, great question. Think about that species identity and how does it match to your goal of what you're trying to get done on the field. Awesome question. Thank you. We got one more question in the chat here. It was just a compliment. Great chat, great presentation. I've got some more questions coming in over text, and thank you to the folks that are sending me a note here with their CCA information. I really appreciate that. I'll get you squared away. If you don't have that app, I highly recommend you get it because it goes straight to your account as soon as you sign in, so you don't have to wait. And this gets really important at the end of the year when you're trying to get all your hours accounted for. So make sure you grab that. One question I have is active carbon testing. I talked about that earlier, that super useful fraction of carbon in the soil that gives you all that utility, that ability to hold on to nutrients, that ability to feed microbes, and I listed all those different benefits. That is a test that's becoming more and more common in our lab system. So most labs are built to measure the nutrients, salinity, pH, cation exchange capacity, a lot of these chemical and physical measurements of soil. What we're now getting into, and is the next frontier of these soil measurements, relates to that biological piece. And so that's where active carbon comes in. So I mentioned it, I'll mention it again. Ask your lab for an active carbon test, and they'll be able to give you an estimate, and it comes in parts per million, of how much active carbon there is in your soil, and they'll also be able to help you out with an interpretation. Is it low? Is it medium? Is it high? I've seen a lot of these tests come back. Most of them are on the low side. We haven't paid a lot of attention to that active carbon piece. It's such a small fraction out of your total soil carbon, and we just now have commercially available measurements for it. We got another question coming in the Q&A, and please keep them coming. I have a question here. What is the importance of the C to N ratio? So I mentioned C to N ratio earlier. C to N ratio can be thought of as your food quality. So just go back to that turkey sandwich versus a bowl of wood chips example. Sure, they're carbon, but they're very different food qualities. So microbes like to eat things that have a C to N ratio between 7 and 10, and they don't like to eat as things that have a C to N ratio that's higher than that. And I'm mainly talking about a lot of those bacteria species that are out there. They have a food quality preference. So the C to N ratio refers to how many carbons are in the food per unit of nitrogen. So if it's low, like a C to N ratio of 7, that's right in that sweet spot of microbial food. But if you try to force feed a bacteria a C to N ratio of 20, that's well outside of that carbon quality, that food quality they like. They're a little fussy. They like high quality food. So ask your ag retailer if they can give that to you when you're thinking about a food source for your field. That C to N ratio matters. And if it gets too high above 11, 12 and higher, that food source quality really starts to go down, and that product might have a better fit. So like a humic acid, not a great food source. It has a double-digit C to N ratio depending on the source, but it's a lot better at holding on to nutrients and keeping them in the root zone where they belong. Great question. Let's go back to the Q&A here. We have a question. I have read that when soil organic matter is greater than 3% on that soil test, humic acids aren't nearly as beneficial as there are plenty of humates within the soil. What are my thoughts? So I'll give you my thoughts. So that's a great place to start, is that soil test. And if you can combine your measurements, soil organic matter percent, that comes on a lot of our soil reports. That's a good place to start. But if you can combine it with that active carbon measurement, what it can show you is, hey, I might have a lot of passive carbon in my soil, but what I don't have is active carbon. So what I've seen here is on these soils that have high carbon and high active carbon, that's where that humic acid might not work as well. But if it's a high carbon soil with low utility, low active carbon measurement, that's where those humics have had a lot more success. So that's where your measurements can help put you in that right direction, where it can help you find the right product, because you might have a decent humic acid load. What you might be missing is the food source, or might be prone to excessive leaching. So great question. It really does underscore that we're trying to make a lot of decisions on these classical soil reports, the ones that include soil organic matter and CEC and texture analyses and nutrient analyses. But as we push into this carbon product, that's where having that consultant to help you understand where is the right product fit. Here's the data that justifies it, and here's the plan to move forward. Tom, thank you for that question. I have an anonymous attendee asked me, do you have a preferred way to measure the microbiome in the soil, especially in regards to using inoculants or active carbon sources? So I'll give you my take on this. And it requires some self-examination. How patient are you and how much money do you want to spend? So there's two factors there. If you want to apply a product and see an instant result of increased microbial activity, that's where some of these Solvita burst tests and Heliae tests could help you out. So Solvita, Solvita, and Heliae, Heney. Your common test, they measure how much CO2 is coming off the ground, and that's an indirect measure of how active your carbon is. So those work fairly quickly. You can make a management decision, apply whatever product you decide to choose, and see if you had an influence on the microbiome. However, that's a very quick test, and it's sensitive to when you took the test, how long since you applied your product, et cetera. So make sure you talk with your lab on when's the best time to measure that. If you have a little more patience, you can do things like measure the phospholipid, the PFLA test, the phospholipid fatty acid test, where you can actually measure the DNA in your soil and construct a measurement of your microbial community from there. That takes a little more time. That takes a little more money to get that done. So if you're a little more patient, you can get that done. You can also look at some of the impacts that having a microbiome has on the field, and that's better soil structure, better water holding capacity, improved soil protein availability, because it's measuring the nitrogen that's moving through that microbial pool. So there's lots of ways to measure soil health and measure the impact of these management plans. It really just depends on how much money you have and how much patience you have. So I just want to say again, reach out to your favorite consultant or favorite lab. They can help you understand what's the best measurement to take based on your own goals and your field conditions, and really help kind of cut away that learning curve that's out there. With regard to active carbon sources, I love that active carbon source test, that POC that I mentioned earlier, the permanganate test. Great way to showcase to you, like, hey, you might have 3% organic matter on your soil test, but you've got very little of it as that high utility carbon. It might be as low as 1%, in terms of that total pie I showed earlier. And that's where you can start making those decisions. Well, is this field, I know I'm low in active carbon, but is this field low in microbes? Is this field low in its ability to complex nutrients? What is this field missing? How do I improve that active carbon pool so I can get those benefits? I have a couple of questions here, or just a statement, about the CCA app. It might take you a couple times to scan the photo, but it will log you in. And thanks for that. Thanks for providing that information. My other question is, are you having good results with brassicas? If you could type some more clarity on what results I'm seeing, because brassicas are fairly unique in the fact that they don't form a mycorrhizal population. So some growers are learning, if I'm going to plant canola, I've got to come back in with a mycorrhizal inoculant after the fact to try to push that mycorrhizal population back up. So again, specifying the product to your end goal. If your end goal is to boost your mycorrhizae, that's a good time to use it after a brassica or coming into a new crop that's rotating in after a brassica crop to try to make that work out. In terms of just brassicas responding to improved microbial food, there's a lot of great products that are out there that'll show that they're responsive to having a higher abundance and higher diversity of microbiome, that they'll respond to that. And then there's also some cool work with brassicas done, whether you're in canola country or even out in the produce country, for brassicas, that shows that, you know, improved nutrient management plans by adding in the humic acid or the fulvic acid. If that's what that field conditions is really setting you up for, that is a great place to slot in that product. So I hope I answered your question. I tried to answer it 3 different ways. I hope I did. I hope I did a good job. Let me open up one more question here. Nope, we got that answered. We're 2 minutes after. Let me provide my email address. If you'd like to follow up, please email me. I'd be more than happy to answer any questions. We'll get this recording out to you within 24 hours. We will also direct you to a white paper that can help you think about these blending strategies. How do I choose the right carbon product, and how do I put them together to really optimize what's going out in the field? And I can't think of a better year to do it. Lots of expected drought, lots of dry soils out there. If you're out in the Great Lakes, lots of wet soils. So we're planting into some challenging conditions, and I can't think of a better time to try some of these new materials that are on the market. And I hope our webinar helped clarify some of these modes of action to help you make a better choice, and make a better choice with a lot more confidence that you're meeting the right goals for your field management. And with that, I'll close. Thank you for your time. Thank you for your attention on this webinar. And I really appreciate all the great interaction. I hope you have a nice day, and keep an eye on your email here in the next 24 hours for a copy of this presentation. And thanks to those CCAs that signed in on with the app and texted me. So I'll get you taken care of. Have a great day. Take it easy.